Oops. Let's see if I can get my screen to share again.
Sure.
Can you all hear me?
Yes, we can hear you. Great.
Very good. Okay, and you can see my screen?
Yes.
Beautiful.
Thank
All
you.
right, thank you everyone. Appreciate you taking some time. It was great. I know Amara worked with some of your colleagues on the MEP 2040 Embodied Carbon and MEP Systems Beginner's Guide that was just published last week. It was really good to learn from some of the expertise there and share that. So if you're not familiar with that, it's a free guide for MEP Embodied Carbon. It's the first of its kind, especially for North America. So I'd encourage you, obviously that's one of my hats I wear, but I encourage you all to take a look at that. I'm going to cover today very quickly in the 10 to 12 minutes, hopefully, just kind of give you all an overview of IESVE. And we'll talk a little bit about AI at the end. And there's obviously a lot of opportunities here, but I'm going to take a little bit different tact and time and expand that circle a little bit because I think it's the responsible thing to do to talk about AI, not just through the opportunities of how it can improve things, but also what some of the costs of AI are or may well be. So IESVE is the software platform. We've been doing this now in this space for over 30 years. We've been around, this is not our first rodeo. Many of you have probably heard of us or worked with us before. And the tool is flexible to be used at really any stage of the design process. So we've recently made some pretty significant enhancements on automation features for the early stages, really trying to close a lot of the loops or fill in a lot of the gaps between the architects and the engineers, especially early on. So there's a lot more that goes into this than just energy and carbon. We need to make sure that our spaces meet the requirements that they're fit for use. So we have good indoor air quality, for example, and that we have the right ceiling clearances, the right light levels. There's a whole lot to this that could be assessed and analyzed. And of course, they're also interconnected. So I've kind of highlighted some of these here on different stages. And of course, a lot of this carries through. And it can get a little bit complex. The different colors are meant to identify where it would be really useful to involve not just the architects early on, but bring in the engineers to do more assessments and to provide their expertise early on. And to do that, you really need a platform that can get into some more of the details, or at least provide a little bit more confidence early on. And this kind of carries through, are very similar in nature to what Amar was talking about, of where you have the greatest impact or have the potential to have the greatest impact. And that, the paradox to that is you're often working with the most number of assumptions very early on. So it can be really difficult in some cases to develop a high degree of confidence that the results that you're getting are in fact appropriate or in fact in the right direction or in the right percentage of delta. So knowing how deep to go and knowing what is being required of your studies at each of these stages is certainly an art form or a craft in and of itself. And across the bottom, you can see I've kind of pulled out some of the things where AI really has the potential to help or to assist with those processes. So gathering of the information is usually a very, very onerous task. Where do you get good information from? How do you tease out the information the client is really concerned with, making sure that you're meeting their other goals and not just their sustainability goals, documenting all of that in charrettes, et cetera. So there's a lot of opportunity there, and we're working on some of these things to be able to improve or take some of the time and some of the opportunity for error out of those sorts of tasks. Well, where we are today is really being interoperable between a lot of different design platforms. So we've partnered with a number of folks over the years, and we continue to develop these partnerships, not just in the context of continuing to build out our own tools, but we recognize that a redundant task of, say, for example, rebuilding geometry that's already built somewhere else is really not something that most people went to architecture or engineering school to do. So we've worked to be able to readily and accurately import Revit models, Rhino models, SketchUp, et cetera, to be able to streamline that process and make that really early stage where you have a lot of assumptions. You can test many, many, many different types of assumptions without having to spend a lot of time reworking, basic things like geometry. Enhancements to the API as well. So there's a very rich feature set for customization, in addition to being able to pick the appropriate level of input. So very high level or very detailed and everything in between. I mentioned some of the automated enhancements. This has been in the software now for roughly a year, and it's continuing to get updated. Our next version is scheduled to have another enhancement to our parametric simulation. So this is a process whereby you can use a simple box model, to represent. Really all you need to know is three things: roughly how big your project is, where the project is going to be, and what kind of project it is. In other words, is it healthcare? Is it a data center? Is it an apartment building? Once you know those three things, you can apply some reasonable assumptions based on energy code and standards, and be able to run thousands upon thousands of combinations and permutations, and then have the software or the tool tell you, well, these are the best ones. What's unique, one of the things that's unique about this is we're not leveraging really energy intensive data centers uses. You can do this from your local machine. So we leverage the fact that you have multiple logical processors on your local PC, so you can spit these simulations out very quickly. We've done a lot of work to speed them up, sort of behind the scenes. And then when you find the one or the ones that are the best fit, you just promote that into back to the live full model, so that you don't have to then rework in another tool, where you're going to start again from scratch. In essence, you can just carry forward the inputs that make the most sense, and then carry on with a more detailed dive as appropriate. It's also important in energy codes and standards to incorporate site context. It also helps with sizing of equipment for HVAC. It helps site PV panels. So, including all of that, we have tools to automatically bring in those types of adjacent structures. We have tools for automatically creating the geometry. So, in other words, I mentioned, you just need to know the size. You can very quickly just tell the software to generate it rapidly for you. It will do that. And then as you carry through, there's a bunch of other wizards and parametric tools that streamline the process of, everything from transitioning from simple HVAC systems into more complex ones. Renewable energy support, including battery storage. So if we want to do a very simple early on evaluation of PV panels, solar hot water, wind energy, and the battery implications, we can do that. Shoebox modeling, carrying this more deeply and also being able to communicate more effectively with all of the stakeholders. So sometimes the engineers will want to give you a big data table with a lot of numbers, and that may cause you to fall asleep. So we can communicate that in much more visually interesting ways. So here, for example, we have a space where we're looking at shades, no shades and shades, and varying the wind to wall ratio. And what we can see is that we've cut the peak cooling capacity, or the peak cooling requirement, from 1.4 CFM per square foot to zero point 0.7. So in other words, we've halved the size of the HVAC system serving that zone. Daylight design, so we support all of the Illuminating Engineering Society metrics, spatial daylight autonomy, et cetera. You can use this for the likes of submitting to LEED under version 4 and onwards. Natural ventilation, mixed mode, CFDs included for doing detailed airflow, indoor air quality studies, indoor environmental quality studies, all of those sorts of things. We use the heat balance method for all of our loads, including the hourly simulation load. So we're getting a very accurate load. For those of you who may be a little bit more technically inclined, if you don't use the heat balance method for like doing an hourly load calculation, you're not practicing good fundamentals. That's not much. Don't take my word for it. That comes directly from the ASHRAE Handbook of Fundamentals, where only an hourly heat balance load calculation, or only the heat balance method, is suitable for an hourly load calculation. Um, Airside systems, we've created lots of different prototype systems over the years. We continue to enhance this. We continue to build out more and more heat pump capabilities, so we can move heat in a lot of different ways, combine a lot of different heat pump systems, do simultaneous heating and cooling, size these systems based on a heating load or a cooling load or some combination thereof. Outputs in a lot of different categories to automate creating equipment schedules or airflow schedules within other design tools. Again, automating the QA or QC process, streamlining that with visuals. And of course, we still have the standardized, if you want to call them that, loads reports that many people are accustomed to seeing. So really trying to talk to everybody that's involved in the design process and help everybody have a common understanding of the decisions that are being made. When necessary, to go deeper into the individual components, so beyond the room level or the building level, digging into heating and cooling coils, fans, chillers, boilers, etc. Understanding the water and energy nexus, whereby when we consume energy, there's usually a water penalty associated with that. So our software will allow you to estimate how much water you can potentially capture off of a cooling coil, how much water a cooling tower may consume on an annual basis. So not ignoring the water question. So I'm gonna, before I jump into some of the AI stuff, just we do a monthly web demo. They're always free. You can sign up there. Typical demo takes about 60 minutes. However, you may want a more specific demo for your organization, aka if you're an architect and you don't want to, really care about all of the engineering stuff, or the inverse may be true. You can always reach out to myself directly, and I'll be able to schedule that for you. So, really quickly, in the last couple of minutes here, AI is certainly something that is disrupting a lot of what we do on a daily basis, and we're excited about some of the opportunities that are out there and exist. I kind of touched on a few of those, but I think it's irresponsible to not talk about the other impacts that AI is having, and namely the environmental impacts and also other impacts on society. So we can't just think about this in our narrow little sliver, because it is such a revolutionary, like something we've really never encountered before in terms of the technological breakthroughs. So I I personally follow a lot of this. There's some concern here because recently, this was published on Wednesday, that AI is 6 times more persuasive than the average human comment. So I think that is a very huge risk when you start talking about, should we trust what AI is telling us or not. It can certainly be more persuasive, for better or for good. One of the things that I think this group probably is most in tune with is the environmental impact. I mean, I've worked in this space for over 2 decades trying to minimize the environmental impact of buildings, and data centers are hugely environmentally impactful. They consume crazy amounts of energy. According to Kate Crawford, currently AI is consuming, it'd be the fifth largest country. If it were a country, it'd use the fifth largest amount of energy of any country on Earth. And we continue to build out data centers to support more and more AI. So it's just some rough kind of translating that of what that means. It is estimated that training GPT-4o consumed about 65,000 megawatt hours of electricity, which is enough to power 12.1 million US homes for 1 hour. Using AI or chat GPT is roughly 10 times more energy intensive than just using a Google search. One study found that the amount of water that it's consuming is it will be very soon 4 to 6 times the water consumption of the entire country of Denmark. And when it comes to embodied carbon and waste, only about 0.25% of the materials that are harvested actually end up being used. So it is a serious AI. Data centers, AI has a huge environmental impact that I think we need to include in that conversation. So that's I can go on, but I'm out of time, so I'm just going to skip there and appreciate it very much, and I'll turn it over to the next person.
Wow, thank you so much, Nathan. Thanks for the great presentation. Thanks for all you've done for the industry, and thanks for all this data at the end. Oh my gosh, next time I'm gonna ask ChatGPT a question. I give it a second thought. Wow. Thank you. So we'll get back to you with some questions.